Hello everybody, today we'll create two custom containers. Both of them will be scroll views, one horizontal and one vertical, and as you can see on screen, these scroll views will have an effect that as you scroll, the items that are not focused, as in centered, will get scaled down and also have their opacity reduced. Let's start by creating the horizontal scroll view. We'll call this the carousel view. Here we'll have a scroll view inside an H tag, and there we will create the views. Now we don't want these carousel views to just be able to present a certain type of view. For that, we'll use generics. We'll declare this content. Content will be of type views, and our carousel view will receive as a parameter an array of contents. Okay, let's leave our carousel view as it is for now, just a normal horizontal scroll view. And let's add it to our tab scene so that we can access it. We'll create a helper function here to create the views in the carousel. It's just going to be rounded rectangles with different colors and a border. Keep in mind, a shape cannot be filled and stroke at the same time. So what I do for that is I fill it, and then as an overlay, I create another shape, the same exact shape with a stroke. Okay, let's run it. And there we have our horizontal scroll view. Let's remove the indicators and add it in a V stack so that the scroll view is on the top section. I will add some spacers with a fixed width on both ends of the scroll view, just so our views don't start on the edge and we can see the effect with the first item. Okay, now what's next? We need to know when the view is scrolling to the edges of the scroll view, that is the screen in this case, so that we know when to reduce the opacity in the scale. For this, we're going to use GeometryProxy. The GeometryProxy has this method frame in a coordinate space, and we're going to use global. So this will tell us when one of the views is scrolling towards the edge of the screen on the device. This GeometryProxy, we get it by using Geometry Reader, a view. Now, for those of you familiar with this, if we were to use it on the view directly, it will make the view increase in size and get position in the wrong place. So for that, I have a trick where I hide the view, and then in an overlay, I use Geometry Reader and actually present the view. This will have the same visual effect as you were presenting the view, but now we have access to the geometry proxy. Now that we have the geometry proxy, we can use it in a function. Let's start with the opacity. We will create a function that takes in this geometry proxy and determines the opacity of the view depending on the position. For now, let's just print the global position so you can see what output we are getting. Let's go here. We already have some output. Do you see the number? So we are getting the frame. And let's start scrolling and see as we scroll, this is getting updated. This is the percent of the view where we want the scroll view to start taking effect. So in this case, 50%, meaning on the first 50% and on the last 50% of the width of the screen, we want our effect to take place. We get the width of the screen with UI screen.main.bounds. And the position, we get it from the geometry proxy with framing.global. If we were to use .local, we will always get the same thing since it doesn't change the position in the scroll view, it just changes the offset. And then for the position, we're going to use min_x. By this, we mean the edges of the square. So that will be the leading edges. So now, if the min_x is less than the percent of the width, then we start modifying in this case, the opacity. So let's not have any formula, let's just change it to 50% opacity and run and see how this looks. Okay, and now you can see as we scroll to the left, the views start getting dimmed. Let's change that percentage to 10% for now. Now let's change the function so that we gradually decrease the opacity. We will do that with a max and min. What we'll mean by this is from one part to the other is where we will decrease the opacity by a percentage. Our max on the left will be the width times the percent of the view, and the min will be 0 since the view will be scrolling just out of bounds to the left. And with that, we can calculate a percentage. We will calculate the percent in a moment. For now, let's just use it to decrease the opacity according to the percent. We'll have a max quantity of opacity that will decrease. Let's start with 0.6 and see how it goes. And to easily experiment with this, let's keep it in a variable. Let's see how this looks. Okay, so we start scrolling and see how it gets dim as we scroll more. Now, let's do it on the right side as well. So we're not checking on the left bounds of the device, let's check on the right. Let's experiment not using the max x, that will be the right side of the square. Let's try with the mid x, that is the x coordinate in the center. For the right side, let's also copy the formula that we're using for the left side with different max, that is the entire width of the view, and the mean will be the width minus the percentage of the view. Let's try once more and see how. Okay, here we got it. See how when the rectangle is kind of in the center, we get the full opacity? That's what we want. Now I like more the effect on the right when we're using the middle, so let's change all of the formulas to just use the mid x. We'll also change the percent of the view to 20. Let's see how it looks. Yeah, I like it with 20%. Okay, that does it for the opacity. Let's move on to the scale. For this, we'll create another function, but with the same formula. Let's declare another variable for the max scale that we are going to reduce. For now, let's make it 0.5 and see how it goes. Okay, see how the scale is reduced on this square to the right? Let's scroll. Good, that's the desired effect we wanted. After sampling with the parameters, we change it like this: 20% of the view, the max opacity is 30%, and the max scale is 25%. And we get this effect, which, yeah, looks kind of neat. Okay, let's add a little bit of polish by just adding some padding vertically. The views don't need to be so separated, and some spacing. Now let's move to our vertical carousel. It's going to be very similar to our horizontal carousel. So much that we're going to copy the view and its helper functions. Let's change the scrolling to vertical, the H stack for a V stack. And for our formulas, we're not going to use the width, we're going to use the height and the Y coordinates. Since this cursor is going to be vertical, we want the views to use more of the width. So let's create another helper function in our tab scene that creates bigger rounded rectangles. Okay, and then we have our desired effect. See how the scrolling looks much nicer. This adds a very neat effect to the scrolling, if you want to. Okay, so the carousel view looked nice using rounded rectangles, a very simple view. How about we using more complex one? In our furniture app, we have this banner section where we scroll horizontally. Let's replace that scroll view with our carousel view. So this is in our furniture project, part of another app, and it has this banner feed section. So let's copy the carousel view here and apply it. Remember, our carousel view needs an array of views, not a view builder. So let's adapt this. We're gonna map the items in the section. That's the only difference. We're still creating the banner cells like they were before in the project. And okay, we're ready to run. Let's see how this looks. Let's start scrolling. Okay, and then we get our desired effect. This is thanks to the fact that the carousel view uses generic, so we can apply it to basically any view we want. But we will have the scale and opacity effects we were looking for. And that was all. We created these cool effects scrolling horizontally and vertically just by using GeometryProxy and two modifiers that come with SwiftUI, scale and opacity. Thanks to this simplicity and to the power of GeometryProxy, we could apply this to pretty much any view as long as it is using a scroll view that expands the width or the height of the screen. Hope you liked this video. I sure had fun creating this effect. Bye.